Hi, good morning. I just want to do a quick update of what I've been doing the last couple of months. I started with the logic board. Aber basically asked me, can you support quadrature encoders? I said, yeah, we can do that. Chip has a decoder built in, so let's do it. And as I was redesigning it anyway, I put on a CAN bus transceiver, I put in inputs for fault signals from drivers, and the CAN bus will allow you to dump any of the values like current and speed onto the CAN bus at whichever ID you like, whichever format you like. What else? Yes, a new power stage. Is it? It's kind of attached to the battery. Maybe you can see it better now. So I'm planning to extend the kit to be a full inverter kit, including the power stage and the casing. So each of these modules handles one phase. Each has its own capacitor, and below there it has a set of 4 IGBTs. Basically 2 in parallel for high side and low side, that might allow an output current of about 200 amps. And yes, it can be populated with 1200 volt parts as well, to allow for some really high voltage controllers. What's special about it? For one, they're really cheap. Cheaper anyway than one of those huge modules, and they can be stacked, so you can put another 3 modules to the side of it and extend the AC bus. It will become over as many modules as you like, and they will all share a common DC bus, and that way you can scale up your inverter to whichever power you need. It will become fairly large obviously, but still. Yeah, so that's subject to more testing. Just by chance the inverter in my Polo broke down because of some loose battery connectors. And yes, so I will be constructing a new one based on that and put it in the Polo and test it in real world. And after I've done that, I think I will be ready to actually sell the kits. Then some small improvements will be made. I've been to Ireland to see Damien, and we discussed a lot of ideas about this and that. And he's doing a Tesla module right now. And he gave me one of these. It's from Paul Holmes' DC motor controller, and it's a current sensor. And it basically bolts onto the bus bar like that, and measures the current as you would expect. And that's great, because I think one of these is like €3, whereas one of these is more like €20. So that will be quite a cost saver, and I reckon it might not be as accurate perhaps, and even if so, it doesn't matter, because the control algorithm doesn't use the currents anyway. It's just used for diagnosis and overcurrent protection, and if that's 10 amps plus or minus, who cares? Then along this, these modules by themselves are non-isolated. So there will be one isolator module, and it has the DC-DC converter for all 3 boards, and a hex isolator, and of course it will come on an actual PCB. I've designed that, and it will also include the DC bus voltage measurement, because there's an isolated voltage anyway. Let's use it for something else. And it will be based on what Damien has done on his combi board, using an isolated op amp. So yes, basically the voltage signal will come from this board, and also I will move the temperature sensor connection to this board, And the current sensors have gone onto the face boards, and that makes this one redundant. Very happy about that. Yes, anything else? Oh, I could talk a little bit about how I'm testing. So that's my test motor. You've seen that in other videos, and my test battery is all 24 volts. Just for some very basic testing. The actual testing goes on in my own car. And to kind of reduce the mess and controlling the inverter, I got an Analog Discovery. It's a USB scope, and it has analog inputs obviously and analog outputs and 16 digital inputs and outputs. So I can control all the signals that the inverter needs by that on my screen. Yes, is there anything else that I would like to talk about? Let's look around a bit. I don't really see much more. Thanks for watching.